right, good morning, guys. So we're going to continue on with chapter 2 here, talking about how to work with rational expressions. Just a couple of things before we start. You'll notice in OneNote the answers to our homework packet are in OneNote, but it's a separate answer key, so it's still there, but I think it's labeled Green Book exercises under the chapter 2 exercise homework packet. But make sure you're checking your answers as you go, and don't be afraid to ask questions if you need to. If you do need to ask questions, you could email me, or if you want to put it in the collaboration space in OneNote, that's another good option that you could do. And if you do put in a question in the collaboration space, you still should email me so that I can know that it's there and work to try to answer that for you. Okay. What else? Your tests, I'm grading them. I'll try to get them back to you hopefully tomorrow. We'll see. If not, maybe Monday. And I'm thinking about being back for your class probably Monday or Tuesday of next week, so you can look forward to that. Well, let's move on here and continue talking about how we work with rational expressions. We said yesterday, you're really not learning much new in this chapter. We're just applying all of our old rules for multiplying and operating on fractions, but applying them to algebraic expressions. So today we'll talk about multiplying and dividing rational expressions. So let's start by reviewing how we would deal with just basic fraction multiplication. If we go back to 4th grade real quick, we'll remember if we multiply fractions, all we really need to do is multiply across the top and across the bottom. So we just multiply the numerators, multiply the denominators, and there's our product. Simplify if we can, always simplify if we can. But that's all. Multiply the numerators, multiply the denominators. So another simple example here. Multiply the numerators, multiply the denominators. 3/4 times 3/2 would be 9/8. Okay, so in summary, multiplying rational expressions is going to work exactly the same way. So when we multiply fractions, we multiply the numerator and we multiply the denominator, and that's all it will be for multiplying rational expressions as well. Multiply the numerators and multiply the denominators. And of course, as we practiced yesterday, we should always leave our expressions in simplest form. So our last step should always be to simplify or to check to make sure that we are leaving things in simplest form. So simplify will be our last step. We'll see actually with rational expressions, sometimes we can simplify it as we go, but it kind of can go in either order. So we'll talk about that in this first example here. But basic steps here, whenever we're multiplying rational expressions, multiply the numerators, multiply the denominators, make sure your answer is simplified. So let's look at an example here. We said to multiply a rational expression, we will multiply the numerators and then multiply the denominators. So if we were to do that right here, real quick, we'd see that this is 3a plus 15, and then I need to multiply that by 12a. And in my numerator, I would end up getting 36a squared plus 12 times 15 would be 180a. And I would divide in the denominator, making sure we're careful to distribute, as I showed here. In the denominator, I distribute this 4a and get 4a squared plus 20a. Now there's a couple things to be very, very careful about. Sometimes we get tempted to say, ooh, a squareds can cancel, and this is absolutely false. Those a squares do not cancel each other. Remember, we can only cancel things that are factors. 36a squared is connected to this addition sign, so 36a squared is a term, and it cannot be canceled. We have to cancel factors only. You'll remember yesterday, we said to simplify a rational expression, we factor, then cancel. So if we want to simplify this, we have to do the same thing. We're going to factor it, then cancel it. So we'll remember, what's our first rule of factoring? take out the greatest common factor. So in the numerator, that greatest common factor is 36a, maybe not obvious, but 36a, and that leaves a plus 5 as our binomial factor. So now those are two separate factors. In the denominator, we have a common factor of 4a, which also leaves a plus 5. Okay, and it might be helpful to cross out the first thing. When you've factored it, you've rewritten it, so it's easy to get confused if it's still there. If we cross it out, then we can just look at the factored form. And now we want to cancel any common factors. Hopefully a plus 5 is obvious. It's a common factor because it's being multiplied to the other factor in the numerator and the denominator. So we're canceling only common factors. We can also notice a common factor of a being multiplied. And also, in 36 and 4, there's a common factor of 4. That leaves 9 behind in the 36. And so, conveniently, everything cancels out except this one factor of 9, and our final answer would just be 9. Okay, so when we multiply all of this stuff together, we end up with a simplified answer of 9. So make sure we're always simplifying, always looking to simplify at the end. And to simplify a rational expression, there's 2 steps: factor, then cancel. Okay, good. Now, it's possible this gets a little confusing to look at, and you could rewrite it out in multiple steps. It's always going to be a little bit confusing to look at. So if there's different ways of writing your answer that you like better, that's fine. And we'll talk about it more next week when I'm back too. But show your factorizations, show the cancelizations. But anyhow, with this example, we can actually see there's a different way of doing this. If we wanted to, we can rearrange the steps a little bit, and we can actually cancel factors before we multiply. And a lot of you probably saw this as I was doing that first example. If we look at this right away, we can see that there's already a bunch of common factors here, right? 3 is a factor, a plus 5 is a factor, 4 is a factor, a is a factor, 12a. We have all these factors here. So if we look at the numerator, we can see a common factor of a canceling right there. So that might be a first question. There's a multiplication sign in between. Yes, we can cancel across a multiplication sign. That is the only operation that we can cancel across, but we can cancel across a multiplication sign. So like these guys right here, they can cancel. Okay. Similarly, a plus 5 can cancel with a plus 5. Now it's getting a little bit clunky to see here. This would be 3 times 12 over 4 is all that's left. 4 is all that's left in the denominator. Now we can see clearly here there's a common factor of 4 that would cancel and leaves a 3 behind, which leaves us with a final answer of 3 times 3, which is 9. Of course, we got the same answer. Any 2 techniques that are both correct would have to yield the same answer. Okay, so this is the basics of how we multiply rational expressions. We want to multiply the numerators and denominators and making sure we cancel any common factors along the way. We can wait till the end to factor and cancel, or we can cancel common factors as we see them before we multiply. It's really up to you. If you have a preference, you'll probably see me doing this much more often. Keeping numbers smaller is preferable to me. But really, if you want to multiply and then factor and cancel, you're welcome to do that. Okay, so that's how we multiply rational expressions. Multiply the numerators, multiply the denominators.